Let f of x equal 2x squared minus 12x plus 13. And we like to express this in vertex form. So that's the form a times x minus h squared plus k. When you have a leading coefficient here, completing the square to turn it into this form is a little bit more involved. So we start off by taking that number, and we're going to factor it out of the first two terms. So we pull a 2 out, and we are left with x squared minus 6x. And then we have our plus 13. And the next step we do is we're going to take this number in front of the x term, and we're going to divide it by 2. Okay? And that's what we're going to put in the parentheses. So we've got our x, and then negative 6 divided by 2 is negative 3. So we have a minus 3. And that is squared. And then we keep this number here, the plus 13. So plus 13. And then we have to subtract, and it's always the same thing. It's always this number squared times the number out in front. Okay, so 3 squared times 2. And then we just simplify a little bit. So we've got 2 times x minus 3 squared. Then we've got plus 13 minus, this is 9 times 2, so this is minus 18. So plus 13 minus 18 is minus 5. Next, we can find the vertex. Our vertex is at hk, right? In this form, the vertex is at hk. So we see here h is 3 because of x minus h, so x minus 3. And k is just the number on the outside, including the sign, so negative 5. Okay. For the x and y-intercepts, we'll start with our x-intercept. We can get the x-intercept from this vertex form by simply setting it equal to 0. And so let me go ahead and do that right here. Okay, and then come up here. We add 5 to both sides, and we have 2 times x minus 3 squared equals 5. And then divide by 2, and we have x minus 3 squared equals 5 halves. And then if we take the square root, we get a plus or minus. We get plus or minus the square root of 5 halves. And then we can add the 3 over. We get x equals 3 plus or minus the square root of 5 halves. Okay, so those are the x-intercepts. X-intercepts are going to be at 3 plus or minus root 5 halves. And then our y-intercept is always very easy to find. We're just plugging 0 into the function. So f of 0, this term disappears, and this term disappears. We just get 13. Okay, and now we're ready to sketch the graph. So we have our vertex at 3. So 1, 2, 3, and negative 5. 1, 2, 3, 4, 5. So there's our vertex. And then our x-intercepts are at 3 plus the square root of 5 halves and 3 minus the square root of 5 halves. So let's go ahead and just plug those into the calculator. We've got 3 plus the square root of 5 over 2, and we get about 4.6. And then we can do 3 minus the square root of 5 halves, and we get about 1.4. So 4.6 and 1.4, those are where we're going to draw our x-intercepts. Okay, and then of course our y-intercept is up at 13, which I think is off this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way up here. And then we're ready to graph our parabola. So I'm going to go ahead and use my symmetry tool just because I'm not the greatest at graphing. And goes all the way up, and it's going to hit the 13. Oh, well, somewhere like that. So there's a sketch of our parabola. And then for our domain and range, the domain for a quadratic is all real numbers. Okay, there's no problems with any number that we'd want to plug in there. And our range, looking at our graph, we see that our range is everything from -5 up. And so our range is -5 to infinity.